Hello everyone, my name is Nick and welcome to this video about Chromatic Aberration 3D fields. So let me quickly go to this little script here, and this is kind of going to the end of the video actually, because I'm going to show you kind of the end idea here, and then I'm going to jump back to the beginning and start describing the investigation, and we're going to go through the basics of chromatic aberration. We're going to be looking at some photographies, and then finally we're going to be seeing some compositing scripts and possible solutions to this problem. So let's say you have a 3D scene here, bunch of cubes floating and spread in space. You have your camera, and then you are giving this render. And as a comper, you're doing the usual stuff, maybe adding a background in there. And at some point, you add your chromatic aberration. And that's all good. This is probably enough for 90-95% of the cases. You're adding a chromatic aberration to the surface of the frame. And it doesn't take into account if these objects are far or close to the camera, but still the effect is kind of enough to mimic the properties of a real lens, for example. Another possible solution to aberrating an image is maybe something more optically correct, and it could be useful for a few cases where the lens kind of renders strong static signatures, strong aberrations, or very noticeable artifacts. So what I did here, and without going into any detail because we are going to go into a lot of detail later in the video, we have this new type of kind of solution where we have our focus point, say, on this middle cube here. So this is in focus, and in front and behind the focus plane we can see that the aberration is different. So for the front aberration I have a rendering of green and blue, and for the background aberration we can appreciate some green and magentas going on. So that's basically it. I'm gonna now jump to the beginning of the video and start going through the basics of chromatic aberration. I'm gonna also be talking about a little bit about bokeh, and also something about spherical aberration, so we can clearly differentiate that one from chromatic aberration. And so that's it. Let's start with the investigation. I hope you enjoy this video, both if you are an advanced VFX artist or a student. Okay, so let's now start defining what aberration is in the context of optics, and as the title says, is a distortion in the image generated by the optical system. So you might think of this as light coming from the real world. The light is now passing through the lens elements and exiting on the other side as aberrated light that has suffered some kind of change, some kind of distortion, and now all these aberrations are being recorded on the camera sensor or film stock. So let's now start our investigation, and even if this video is going to mainly be focused on chromatic aberration, I would also like to describe spherical, because I think it's also very present in our everyday job as compers or visual effects artists. So let's now quickly touch on the subject of spherical aberration. As this definition I wrote here says, in spherical aberration, the edges of an image look a bit soft, but the center still sharp. It occurs because not all the light rays land at the intended focus plane, but still very close. Results in loss of sharpness, especially at big apertures like 1.4, 2.8, and those kinds of like big aperture values where we have a very shallow deeper field. So let me talk about this graph in here. We have two pieces of glass. So on the left we have what is kind of a perfect lens. This lens doesn't exist in the real world, so we can see the light rays all being focused at a single point in here in the focus point, and then being mirrored out on the other side. And what we can see is that the light maintains a spherical shape as it comes in and out of focus. So you can see how every ray kind of draw a normal angle, like is kind of 90 degrees from the sphere here, from this circular shape. And so the way these light rays revolve around describe kind of a circle. On this side we have a lens, a real lens that we can find, and so you can see how the light deviates from the spherical shape as it comes in and out of focus, and results in loss of sharpness, as this definition says here. So you can see how not only the rays are no longer focusing on a single point, but we have multiple intersections lying around very close to the focal plane. So here we have our focal plane here, and we have some of the rays being focused at the focus point in the center of the frame. That's why kind of the center area looks sharp, but the edges and corners of the frame here are gonna look more blurry. Also, you can see how the rays are describing a more oval shape or an ellipse instead of a perfect circle. So let me now go to the next slide, where we can see an object or a ray of light being shined through the lens, and we are having same kind of representations belonging from the same object, but these same representations are getting progressively out of focus as we go through the edges or corners of the frame. So let's imagine this circle is an object, but we are having that same object being drawn or rendered by the lens in kind of these circular representations or concentric circles, but all of these circles belong to the same focus plane from the same object. So let's now kind of try to make sense of this in a more clear way. Let's imagine we are trying to film a grid in space. So here you have your grid floating around, and you are putting your camera 90 degrees towards this grid. You're focusing on the grid too. So now our focus point and focus plane coincides exactly with this grid, and the output of that would be something like this. So we are getting some spherical aberration with this lens, and what you would see is exactly what the definition says. You are seeing some sharpness in the center of the frame, so this grid object is being rendered in focus, but as soon as we get to the corners we can see some spherical aberration starting to be rendered in these areas, and you are going to perceive those areas as being out of focus, but that's not exactly what's going on. That's actually spherical aberration and is kind of a more of blurry perception of the same object. That doesn't mean that this is looking out of focus because it's closer or further away from the camera. That's not what's going on here. We are focusing the grid in the entire surface of the frame at a single depth focal plane, and we are still seeing the center sharp and the corners more blurry and mushy. Let's now see a real photograph showcasing this effect. So here you can see this sign on a wall, and here we have this kind of fisheye lens, and you can see how the center is looking sharp. All these letters are looking in focus, but as soon as we go to the corners, we see how they get more blurry, and we are losing some sharpness in this focal plane. So again, everything is at the same depth, but still we see some loss of sharpness towards the corners. So here we are in chromatic aberration, and I wrote this definition here that says produce color fringing or color separation. It happens because different colors of light bend differently, refraction, when passing through the lens system, causing them to focus at slightly different points. In areas of high contrast, you might see a bit of color distortion. So this word here is very important, refraction, and we are going to explain why in just a second, but think of chromatic aberration as an interaction of the physical properties of light and also the physical properties of the glass in the lens. The interaction of both is going to cause chromatic aberration to be recorded in the camera sensor. So let's now take a look at this graph, and is the visible to human eye light spectrum. You can see the colors going from red to violet on the right, and the wavelength going from the 700-ish to the 400s, and they are measured in nanometers, and you can see that red is the lowest frequency from the visible light spectrum and the violet is the highest frequency. So this kind of property of the light is going to be one of the main things causing refraction on the lens. So let's remember this property, and let's now move to the next graph. So here we have an image of a photographer, and here you can see a lens attached to the camera. And now, by the magic of digital compositing, we are going to travel inside the lens. You ready? Here we go. So there we are now seeing inside the lens. Here we have a glass element. We see the light going inside the lens and the sensor or film stock in the back. So let's now focus on this graph, and let's zoom in a little bit. So you are having the light from the real world going through a lens element, and then is being focused at this point called the intended focal plane. You can call it the focus plane, and then is being mirrored out and being recorded in the sensor or the film stock. So pay attention at how the light going through the center of the lens remains white, just like the light from the real world. So you can imagine the white light as being the one not being aberrated or very, very slightly aberrated, and is getting through the intended focal plane and being mirrored out on the other side and is hitting the sensor. But then you have the edges of the glass or the periphery of the glass, and you can see how the light from the real world is getting distorted and separated into different colors. This is because different wavelengths of light are going to bend at different angles inside the glass or the new medium that the light is going through. And then because it bends at different angles, it also focuses at slightly different depths inside the lens. Let's quickly define what the circle of confusion title is, and even if this is going to be a chromatic aberration investigation, I think it's also good to touch on other subjects that are gonna go in and out of this video, and we cannot avoid because they are also related to all these artifacts of aberration. And so let's define the circle of confusion as the parts of the image that doesn't belong to the intended focal plane but are still perceived as sharp focus to you, the observer. So you might be looking at a picture in your computer, or maybe a printed image you're holding in your hand. You look at this picture and you can distinguish the areas being in and out of focus, and you also clearly see the area in focus. So the circle of confusion technically is areas that fall outside the focus point but are still perceived as in focus to you, the observer. Doesn't matter if it's behind or in front of the focus plane, you're gonna still see an area that is in focus to you. So here we have this photographer, and as we can see, she's taking a picture. And let's now add two sets of rays, one entering from the left and going through the center of the lens, and the other one is coming from this angle and going through the edges or the periphery of the glass element. So let's now analyze what these two rays might look like if we look at this picture. So we can see that the center ray is being recorded in the center, and as we can see, it's not suffering from much aberration, or maybe in this example doesn't have any, although all the surface of the frame in a picture is aberrated. We can clearly see this effect to be more noticeable towards the corners of a frame. So let's now focus on that area, and let's add the other ray. So now we have the ray entering from the edges of the glass, and we can see how is recorded by the sensor as slightly aberrated. We can see some color separation, some green on this side, some magenta. So yeah, I guess I just wanted to point out this very kind of basic phenomenon happening with aberration and the corners of a frame. So here we have Marcy in the 3D world, and she is representing the light coming from the real world without any aberration. And let's now pass Marcy through a lens. So here we have our lens. We have the camera sensor over on this side, and over this side we have an arrangement of glass elements representing the lens. So the light from the real world is going through the glass elements and coming on the other side as being aberrated light. The red rectangle here is representing the focus point. So this is where the image is going to look in focus. And we can see two areas, one the front aberration field, and the other one the back aberration field. So this area belongs to the parts being close to the camera, so they are the area from the focus point to the camera, and this area over here is from the focus point to the infinity, or further away in the distance, so far away from the camera. We can see that the light enters, gets aberrated, and we can see a set of colors here just as an example. So whatever it was blue aberration on this side has turned into green aberration here. Whatever it was red aberration on this side still remains red, which is an indicator that probably this red ray is just going exactly through the center, through the focus point, and being recorded on the other side without any aberration. And then we have this yellow light that now has turned into a magenta or pink light on this side. So then all these aberrations, both the one in the front area and the back area, they are recorded all together, and they are landing on this camera sensor or film stock. And all of these aberrations, both front and back, are being recorded in the camera sensor. So let me quickly go to the ray simulator here, and we have a piece of glass here and a light source, a single beam, and let's move the beam through the glass, and we are going to see a few things happening here. So if we focus the beam on the center of the glass, you're going to see that goes through the glass without being affected and comes out on the other side without any type of change or aberration, or like the beam is not suffering from almost any change and is going out on the other side aligned to the same point that it came in. But if we move the beam to the edges of the glass, you can immediately see how the beam enters the new medium and bends and comes out even at a different angle than the one that it has inside. You can also appreciate some kind of internal reflections here happening in the glass. This is something that is minimized with treatments in real lenses. But at the same time, this is for another tutorial, but this is one of the things that causes lens flares in lenses. But letting that parenthesis aside, let's continue with refraction here. So you can see that the angle of the beam gets changed towards the edges of the glass and not so much or almost zero on the center. So let's now change the wavelength of these beams. As I was telling before, the wavelength of the light is measured in nanometers in this case. So let's place this beam over here, and let's change the frequency of the light. So we are going from violet all the way to red. If we pass red, we can no longer see that as humans, and the same on the other side. But look at how from violet to red, how the light changes angle also, not only because it's entering a new medium, but also because every wavelength is changing angle inside the glass too. And that's the principle of what is causing chromatic aberration. If we go to the center of the lens and we change the wavelength, we are not going to see any change in the outcoming angle. So I thought it was interesting to to show you in this very simple example how the angle changes according to the wavelength and the frequency of the light. Another factor that is interacting with this wavelength is the properties of the glass itself. So if we change this coefficient here, you're gonna see a massive change in the angle too. So the glass itself also causes the bending of the light. So yeah, this is maybe for another tutorial, the properties of the glass itself, but it's important for you to know that it's an interaction of both things, both the wavelength and the properties of the glass. So what happens if we select this light coming from the real world, and in this case is green, and we play and change the wavelength? So what you can immediately see is two things. First, the light is bending differently because we are changing the wavelength. So this is in nanometers too. So in the violet we have around 400 nanometers that bends at a given angle, let's say, I don't know, 8 degrees or whatever. And if we go to the other end and we see red, the red has a lower bending angle, and this is causing the red to focus kind of in this area, and the violet is kind of focused in here. So this is a clear example, and you can see it right in front of your eyes how different wavelengths of light are gonna bend differently, and for that reason are gonna focus at different depths in front or behind the intended focus plane. Another cool thing to see in the simulation software is, I don't know if you remember what I was saying about this graph, that the light rays passing through the center of the lens were going to be less aberrated than the ones passing through the edges. So sometimes, depending on the aperture value you are using in your lens, you are going to see more or less aberration, and this is why. So the light, the rays going through the edges of the glass get more aberration. So here we have this aperture blade in here. So if I kind of use a bigger aperture value, we are going to be suppressing the light rays that passes through the edges of the glass, and we are only getting the ones going through the center. So these are the only rays that are passing through the lens now, and are the ones going through the center. Thus, for that reason, are getting the less aberration. And if we use a smaller aperture value, so if the hole letting the light is bigger, we are gonna get the rays going through the edges of the glass, and we are gonna get more aberration. The good thing about a smaller aperture value is that you get more light through, and the image it's brighter. So this is something that you might want to use if you are in a low light situation, or if you want to isolate the subject, so you're gonna have less depth of field, and the area in focus is going to be smaller. And if you use a bigger aperture value, while it's true that you're going to have less aberration, you're also going to let less light in, so you kind of need a good source light in the real world. But you're also going to get a bigger depth of field, so more areas are going to be in focus, if that makes sense. But yes, I guess I wanted to show you that kind of in action in a simulation software, and make you see how the different wavelengths bend differently and get focus at different depths. So here we are in the Ray Optics simulator again, and what you can see is the kind of a very simple way to describing the color spectrum going from red to violet by these light sources. Here we have an aperture, we have a glass, we have the intended focus plane, and here we have the camera sensor or film stock where the image is being recorded. So let's start with the red spectrum. We are getting a bending in the glass and a focus point around here. So let's now just continue to put all the colors from the spectrum kind of in line. So I'm gonna have to zoom in here, and kind of what I want to do is put them aligned so we get kind of a white light coming from the real world here, and different bendings happening inside the lens, which are very difficult to see, but as soon as we get out of the lens, the light aberrations are more obvious to the eye. And then we have all the multiple intersection and virtual kind of focus planes all over the place in here in the circle of confusion. But we have kind of an area that we can call kind of the average of focus, which is here. So you're gonna be moving your focus ring in your lens until you get kind of the focus that you want. So, and then the image is recorded on the other side. So what I want to do here is I want to increase the ray density. So we are getting more rays, and you can kind of see the area of focus has been kind of in here. But let's take this out of the way, because the main thing I want you to see is how the aberration is different in front and behind, both sides here, in front and behind the focus plane. So on this side, closer to the glass elements of the lens, we are getting an aberration that is kind of been rendered as yellow, reddish, orange, and on this side is getting rendered as more violet blue. And another thing that I want you to see here is how the lights coming from the center of the glass are getting less aberrated. So the ones getting through the center of the lens, you can see this kind of white light, kind of tunnel of light in here, almost not being aberrated at all. So yes, the main purpose of this demonstration was to show you the different aberration hues in front and behind the focus plane. Also, if we close the aperture, we are gonna be letting out the rays going through the edges of the glass, and for that reason we are gonna get, with a bigger aperture value, we are gonna get less aberration. So we are almost getting like a sort of white light, pure light, with almost no aberration. and as soon as we use a smaller aperture value, we get all the aberrations from the edges of the glass. So before we move into practical examples of photographies and some videos I want to show you, I just wanted to do this last stop on the lens simulation software and talk about these two examples you see here. The top one is about lens bokeh, and the bottom one is about chromatic aberration as a last example, similar to the previous ones, but more with a practical example with subjects, and same in here. So even if this video or investigation is not focused primarily on lens bokeh, I think it's important to show this to you because at some point later in the video we're going to be seeing some bokeh shapes and we're going to be talking about them. So in this example we have the real world on this side with these three subjects. So this is far from the lens, this is close from the lens, our lens is here we have an aperture, and now we are inside the lens and these three subjects are getting mirrored inside. So this subject close to the lens is this one over here, the middle is the middle one, and so forth. This oval bokeh shape represents everything being close in the real world. By close I mean anything being close to the front of the lens, and everything being a round bokeh shape is anything being far in the real world. So let's say this subject. And this small circle is represents sharp focus. So let's say we are focusing on the middle subject here. So anything being close is going to be rendered with this oval bokeh shape. So this subject is going to be described with kind of this oval aesthetics in the rendered image, and this subject, which is the far subject here, is going to be rendered with this rounded bokeh shape. And the bokeh shape is dynamic because if we are racking focus, that means that the bokeh is kind of going from rounded to oval or oval to rounded, depending on where we are focusing. So at this point this subject might have some kind of bokeh, but if we are focusing even in front of that subject, this subject now has a different bokeh. So this one is more neutral, this one over here has a rounded bokeh, and this one over here is gonna have a more oval one. So now let's talk about chromatic aberration in a similar example. So we have all our wavelengths coming from the real world. The light gets aberrated in the lens system. So let's say this is a zoom lens. Here you have your camera sensor, and again the chromatic aberration is also dynamic because let's increase the ray density here. So at this point we are focusing on the middle subject, and you can clearly see the subject being on the far side of the world. So is this subject over here, that inside the lens is getting like kind of a violet blue aberration, and the subject being closer to the lens on this side of the focus plane is getting an orangey yellow red aberration. and the subject being in focus is very neutral. It almost doesn't have any aberration, but everything changes if what I want to do is focus on the closer subject. So now the closer subject is in focus, and the other two are the ones inside the aberration field that describes or rendered a blue and violet aberration hue. Things are going to continue to change if I now focus on the subject on the far side, and the other two subjects are going to fall into the red aberration field or the orangey field. So now this subject is neutral, and these ones are in the orangey red aberration area or field. And again, as I was saying, chromatic aberration is dynamic. Maybe you're not rack focusing. Let's say your focus is now in this area, but if these three subjects move in space, so they get closer and closer to the camera, they are walking and getting closer to the camera, you can see that now they are suffering from different aberrations. So now the middle is neutral, but then it's going to step into the reddish orangey aberration field. Now this one is here and it's more neutral, and they continue to walk and advance towards the camera, and now the three of them are inside the aberration that is more like orangey red. So this can happen because you are rack focusing, or because the object in space is moving and is going through all these aberration changes, if that makes sense. This is gonna definitely make sense later. We're gonna see more and more examples from real photographies, and you're gonna see exactly what I mean. So let's now start talking about real world examples and see some photos and videos. And let's define chromatic aberration 3D fields as the different aberration hue shifts across depth, and are divided by the focus plane in two main groups, and I call those groups front and back aberration. So if we look at this graph here, and I promise you we're not going to be looking at any more boring graphs, but I want you to remember this, because kind of for you to keep this graph in mind when we see the photos and videos. So this is our circle of confusion. This is pure focus, but this circle of confusion is still the area that we perceive as being sharp, and this is what I call so this would be back aberration, and this one is front aberration. So you have this, like these two areas, front and back aberration. That's all I wanted to show you, and let's now go to start seeing some examples. Before we do that, I want to, in case you're interested, show you what's the equipment I'm using to show you these examples. So the camera, I have a Fujifilm X-T1, which is a crop sensor. So I'm using full frame lenses. So yes, we are going to be cropping a percentage of the image, but we are still going to be able to appreciate all these lens phenomena anyways. But just out of curiosity, I'm letting you know that I'm using full frame lenses, 35mm lenses with a with a digital camera crop sensor. And about the lenses, I'm using the Helios 44 f2 58mm, the Konica Xenon f1.4 57mm, and the Canon FD f1.4 50mm. Being the Canon the one that I don't have identified in the pictures because it's very similar to the Konica, but I have identified the Konica and the Helios, and those pictures are going to be labeled. Funny thing about the Helios 44 is one of the lenses being used on the movie Dune Part 2, although the lens has been rehoused in a way that the lens can record metadata and is motorized, and is a very modern housing for this glass. The glass itself is still the same, so yeah, I thought that was a funny side note for this little lens here. So cool, let's go to the fun part of this investigation, and let's begin to look at some pictures. So here you can see a picture of a blind I took at home, and you can see I have marked in blue the circle of confusion. Or actually, what is the crinkle of confusion, guys? Can someone explain me what a crinkle is? The crinkle of confusion. So circle, the circle of confusion. That's it. Although the crinkle was a cool word. And so here we have the foreground area, the circle of confusion, being the pure focus in the middle, but still these areas are being perceived as being sharp. And then we have the background area, and you can immediately see the background aberration is green and kind of this orangey, although this orange is coming from the color of a wall outside that is kind of not pure white and is tinting the light this color. So just focus on this green, and you can see some cyan and then some magenta on the front aberration. So this was the thing I was talking about here when I call this front aberration and back aberration, is this thing you are seeing here. So let's change, let's rack focus on this blind, and now I'm focusing even closer to the front of the lens, so the entire blind is in the background aberration area now. So that's why the entire blind is now this magenta, this cyan color, and we are seeing cyan all over the surface of the frame. And then if I focus on the back side of the blind, everything is gonna get tinted with this magenta color all the way to the area where we have the circle of confusion. So the circle of confusion, we can say that this lens actually is rendering like 3 aberration main colors. So let's copy this constant I made here, and let's say this one is the center, or sharp focus, and let's sample this color. So you can see these constants here I made for the front aberration, the circle of confusion or the sharp area, and the back aberration. So that is the sampling of, let's say, this magenta over here. The sharp area is rendering this cyan, and the background is rendering this green. Let's go to these pictures that also were taken with the Konica, and these pictures belong to another session that I did on the screen on a TV. So I projected, I put a grid on the television and just begin to rack focus at different areas. So the camera is a little bit to the side of the screen, and you're seeing the screen in perspective, and you can see immediately the same rendering that the lens was doing on the blinds. You can see the same colors and hue shifts on the grid, although it gives you more precision on how the hues are slightly changing. But roughly you have this cyan on the circle of confusion, pure focus, and then it gets magenta, and then it gets green to the other side. Let's continue seeing some. So what you're going to see is how the camera racks further away from the camera, so you can see the front and back aberration areas very clearly now. Another thing to notice is see how the front bokeh and the properties of the blurry on the front area is kind of more blurry than the back one. So the back defocus or bokeh is more sharp, and the front one is a little bit more soft. So this is something that I have seen in the majority of the lenses, no matter the lens model or the focal length. I have always seen that the front defocus properties are blurry, more blurry and less sharp than the back area. And so I probably continue to rack focus here until yes, so I said soft blurry bokeh defocus and sharp bokeh defocus. So that's it for this example. It's a very kind of scientific way to kind of show how the aberration behaves in this Konica lens. And let's continue to now see at some more examples. These ones I did with my computer monitor, and the camera is facing the monitor 90 degrees, so it's just in front of the monitor. And I created this append clip. And one thing to mention is you can obviously see that I am color correcting. What I'm doing is just increasing the saturation so you can appreciate the change in hue better. But even if I don't do that, you can see how this aberration, without changing any color and interpreting the color space of the camera correctly, you can still clearly see how things go from this cyan, from this magenta to this cyan and this green. But for the purpose of visualizations, you're always going to be seeing exaggerated, saturated images. So let's go to this clip here, and what I'm doing is I'm still on this Konica lens, and I'm racking focus towards the computer monitor until we get to the sharp or the circle of confusion area, and then I'm passing the focus plane, so I'm going through the monitor all the way to the other side of the monitor, and now we are in the background area, and we get this defocus properties. So again, see how the foreground defocus or bokeh looks softer than the background one. So you can see more this, you can read like these lines, and in the front one is a little bit more confused and blurry. And let's talk about the colors. You can still see the magenta on the foreground, on the front aberration. Then we get on the monitor surface, and things turn this cyan color. And also when you point the camera front to the surface, you can see kind of a cyan in the center, more green-ish on the sides. Then we pass through the monitor surface and things. We are beyond the monitor now, and we are in the background aberration area, and everything is green aberrated hue. So let's go now to this example. This is going to be similar, but this is now the Helios 44. We are probably shooting at f2, so we get maximum kind of bokeh rendering here. So you can see also I'm pointing the camera to the screen, and we get kind of magenta on this area here, but the focus now is here, and we are seeing some greens turning into magentas all the way to this kind of blue. And now I'm focusing on the center of the screen, and we are getting the background aberration on this side and the foreground aberration. You can also see how this lens is does this swirled bokeh rotational effect. So the bokeh is looking very different in the edges. But going to the main subject, that is aberration, this lens is even crazier because not only changes aberration in this axis, let's call the Z-axis, is going from green to blue, and you can see an immediate change from this green to this magenta. So this is the pure focus area, this is the circle of confusion, and then you have this green and this magenta kind of blue here. So this is more complex, this is a more complex lens. But if I were to guess the main two colors or three colors that describe this lens, I would probably pick this green and maybe this magenta and then this blue here, just to simplify things. But this is an even crazier lens because you also have rotational change in aberration. So you have this blue here, and then you have kind of these tobacco colors or maybe green over here, and then you jump to these greens and bokeh changes. I would like to make a brief parenthesis and talk a little bit about sunshades and lens hoods on lenses, and how these blockers of light can also affect the shape of bokeh on lenses. So for example, we have this director of photography here, or cameraman, and we can see the front of the lens, and here we can see a little sunshade put above the lens, so he is kind of blocking some sunlight from the top, and you can see the projected shadow on the front of the lens. So this is probably to avoid lens flares and those kind of things. So here I have another picture where you can clearly see some blocker here. Here we have Quentin Tarantino filming on an Ultra Panavision 70 camera, and he's not only using sun shading or lens hoods on all four sides of the lens, but he's also extending another one in here. Here you can see another blocker kind of in a funny angle, and another one on the side. So sometimes, you know, a lot of light treatment is being done to the lens in order to achieve the desired look. It all depends on the situation and what's going on, but yeah. So here you have another example. This is also a little bit of a lens hood here, but it looks like this situation needed some extra blocking on the top. Here you have another case, an old picture. So here you can see the lens in here, and here you can see kind of a rig and a little screen on the top to block some sunlight. Another very simple lens hood in here. And finally you can see how in this situation this looks like an indoors, also an Ultra Panavision 70. Yeah, so this is probably the Quentin Tarantino film. And here you can see a blocker on the top, another one on the bottom, but not on the sides. So it all depends where do you want to block light from. So they probably want to block a light on the top here, so you can see you can see a little bit of the light coming through, but the rest of the lens is receiving kind of a flat lighting, and is not gonna create any lens flares or funny artifacts. So the way you would see this on a test situation I did here. So we have our lens here, still the Helios 44. So, and I draw these red lines on all four sides of the frame. So whatever the red line is where the light blocker is where I'm blocking the light in these tests. So you can see like I'm blocking the light from the top, and when the light blocker comes in, you can see I'm moving a little bit the light blocker in and out, and you can see how the blocking of light is changing the shape of the bokeh. It's like slicing it in half, and you can see half of the bokeh or the complete rounded one. So for example, if you block the light from the left side, and the moment you block the light, you can see how the bokeh shape changes. This is also going to change the image itself. So the image, if you see a full picture here instead of these dots on a screen, if you were to see a plate of or a picture of a subject or whatever, you would perceive how maybe this area would look sharper and this area would look more softer. So it's going to change the rendering properties of the lens. That's something to be aware of. That's how powerful the treatment of light is. It's not just that you are blocking light, you are also changing the rendering properties of the lens itself. So when you block the light from the top, you see a slice at the bottom of the bokeh. When you block the light from the bottom, you see a slice on the top of the bokeh. And when you block the light from the right side, you see how it's getting slides on the left side of the bokeh. So I thought this was an interesting thing to mention, and let's now continue with the rest of the demonstration. Let's now continue to see a few examples. Let's see this one from the Konica Xenon here. So we have the same picture, but in the first picture I am focusing my lens on this light dot in here. So this is kind of an array of lights spread in space, and we can see how the bokeh in the center is a little bit more rounded, and we are getting on the edges of the frame and further from the frame. So this would be the back bokeh area, and this is the area in focus. So the front bokeh area is being let out of the frame right now, so it's behind the camera actually, or virtually speaking, if you know what I mean. And now I'm gonna focus on this light over here, and you're gonna see this light getting out of focus. So there we are. So now the focus is on this area, and the front bokeh field is now in frame. So if we switch between the two, you can see that the front bokeh again is much softer, a bit more rounded, kind of more a gentle bokeh and not so contrasty. And as long as we go to the center, we get more contrast and more brightness. And also you can see how the front bokeh is softer and compared to the one at the back that is more cat eye and sharp. It feels more sharp for that reason. I wouldn't say it is actually that the image is gonna be sharper, because I'm not saying that, but the blurriness itself, it is more like defined, and you see more frontiers and kind of geometry going on, and this is more blurry. Things are gonna mix, and it's gonna get more mushy in the lens on this at this depth. And whether in the back bokeh area, things are gonna be perceived as more structural or more sharper, or maybe more geometrical in the aesthetics or in the rendering. So let's continue with a few more examples. So let's take a look at these two pictures. I don't remember the lens for these two, and also I don't have metadata because these are lenses that are not modern glass lenses, so we don't have any communication to the camera. And if we saturate this picture, you're going to see that the background bokeh, that the background aberration is more green, on the green side of things. And then we are getting to the area of focus, maybe it's a little bit more neutral, but then as we begin to transition to the foreground bokeh area, you can see these reds beginning to pop in. So you can see this kind of red magenta, again red, pink magentas going on the front of the lens, on the front on the front aberration. And the back aberration is a bit more on the green and the aqua green side. Then let's take a look at this picture here. So here's where you have to begin to pay a little bit more attention and really look to what's going on. So we have the focus area probably in this branch around like this area over here, so these edges look more sharp. But as long as we begin to go to the foreground or the front aberration field, we begin to see a very clear blue aberration on the high contrast edges, as you can see. And then as we begin to reach the in focus area, things get a lot more neutral, or maybe not aberrated at all. And things being further away in distance, like these buildings in here, so the background, or the background aberration is more on the green side. It's more like an orangey green aberration in the back bokeh. So here you have back bokeh aberration alongside the front aberration. Sorry if I say bokeh, I didn't mean to say bokeh. We are talking about purely about aberration here. So here you have a front aberration being blue and back aberration being green or sort of orange. Same here, you can see the green aberration in the background. You can see this in these more defined bokehs. In here you can see those greens, those oranges. You can also perceive them in this area where you have all these bokehs rendering in here. You can see all those nice green aberration edges surrounding the bokeh, and then you have more kind of an empty bokeh with less aberration. So this is a kind of a nice example where you can appreciate both front and back aberrations. This is another picture. This is my watch, and this was taken with a Konica Xenon, and if we saturate the image, we can see exactly the same behavior that we were seeing at this picture over here. You're gonna see a front magenta aberration transitioning to a more desaturated and then getting green, and then so if we go to this picture of the watch here, you're going to see the same. You're going to see these magentas or reds. So in this particular situation, under this aperture and this light, looks a little bit more red and is transitioning to the green in the background aberration. So you can clearly see the magenta reds and the greens in there, and here you see the same. This is a more neutral, so this is the circle of confusion. You can still see this picking up the magenta aberration, but it's still sharp. This is picking up some green aberration, but it's still sharp. So this is kind of the area perceived as being in focus. So this is our circle of confusion. You can also see some. So now we have this video. This was shot with a Konica Xenon and the Fujifilm X-T1. So we have this plate with the water, and what I'm doing is I'm rack focusing. So at the beginning of the shot we are completely out of focus, and what we are seeing at the beginning is the foreground aberration. So as soon as I bring the focus plane in from the top of the frame to the middle of the frame, I'm bringing the background aberration field in. So both fields, the background one and the foreground one, are moving solidary and together inside the image. So I have stabilized this and saturated, and if we see this, you are going to see more clearly how on one side I'm sampling these areas over here, so you can see how the aberration changes from a more, so and again it's the same behavior as the other pictures. Your foreground aberration is going to be kind of the warm side, and the background aberration is going to be kind of in the cold side of greens and maybe some cyans. So yeah, you can see how the entire frame shifts from those oranges and shifts to a green as soon as the focus point comes into frame. What you're seeing right here, This was generated with a Voronoi gradient gizmo, so I'm sampling 4 points separated on the surface of the frame, and you can see how the sampling changes over time. So kind of how the foreground aberration remains a kind of orange or yellow, and the background aberration is shifting towards the greens. And I mean, it's very easy to see what's going on. So not only the high contrast areas are changing, but also you can see these surfaces are like turning green. Look at this edging here, how it shifts from immediately from a magenta to a neutral and then into a green. So yeah, at least in this plate is quite noticeable. And if we see the first frame and the last frame, like, you can really tell the difference. So here we have a few more pictures, and in this example we can see a very narrow deeper field, and if we zoom in we can see this kind of violet and kind of pink magenta aberration. And when we go to the circle of confusion, we can see it gets a little bit more neutral, and this kind of grainy substance is not suffering from much aberration. But as long as we get to the back aberration field, we can see these oranges across the surface of the frame. So we can say that this lens is suffering from a magenta foreground aberration and an orangey background aberration field. We don't even need to saturate this picture. Just by looking at the natural color, you can see the two aberrations very, very clearly. And let's take a look at this one. In this case also we don't need to saturate the colors to see we have a magenta aberration in the foreground and a green aberration in the background, and the circle of confusion where the focus plane is more neutral. Let's take a look at this one. We're probably going to need the help of saturation here. This is a picture I took in Sydney, Australia, on a bridge, and was taken with a Fuji X100. It's a pocket camera for street photography, and if we saturate this, we can see this kind of orange aberration in the foreground field and transition into a magenta, and then here we have the focus plane. So this is kind of the circle of confusion, and when we exit this area and we go into the background field, we can see that the aberration has turned green. So roughly we have orange, magenta and green, and like 10 or 15 meters away we still see that the background field remain consistent, and we still have this green aberration going on. So it would be a green and then a magenta and then an orange. We can say this lens is made of three kind of aberration fields. Two of them are in the foreground aberration, and the green one is in the background. Here we have a picture of a woman in the water, and we can see without any without forcing the saturation, we are going to see that we are seeing some red, or I would say it's a red aberration here in the highlights. So we can say this is a red foreground aberration field, and then we continue to see that behavior and rendering in the lens. You can see those reds, those oranges, like in here, for example. So not only in the highlights, but also in the midtones, everything is kind of tinted red and orange. And then we get to a less saturated area. This is more neutral. This is the circle of confusion. So this is where the focus plane is, but still all this area, it is kind of perceived as being sharp, and on her edges we don't see really any type of severe aberration, because it's where the focal plane is. We can see some aberration here though, but she's looking like very neutral, not much aberration going on, because she is inside the circle of confusion. Again, in here, this is looking very neutral, but as long as we pass the circle of confusion and we get into these areas, we can immediately see this green, this dark green kind of halos around the highlights, and this remains consistent all the way far away from the camera. So we can see these bokeh shapes here also describing some green, same in here, so we can confidently say that this lens is made of like two main aberration fields, the foreground aberration field being like kind of orangey, and the background one more on the greens. So now I would like to show you this sequence of images here. We have a couple of pictures and a few videos taken from the same angle, and so you can see this kind of walk alongside the river. This is Camden in London, and I'm focusing on this side of the wall, so this is where the circle of confusion is, and here you can see the foreground field, and the background field is the rest of the picture. And if we take a look at the colors, you can see some red foreground aberration turning into an orange, a little bit of a pink, and then after the focus point we see things turning more into a cyan and green hue aberration. The same further away in the distance, you can see these cyans. So this is kind of an artificial lens. I think this was the Canon, one of my Canon lenses, but I don't unfortunately remember exactly which lens it was. But you can see that the aberration is not looking very vintage. It's like kind of modern. It's doing these crazy cyans, and then it's getting more into this blue. As soon as we get closer to the focus point, then we see a few pinks, then a bit more neutral, then we get into an orange and a red. So this lens is very rich in the amount of fields and hues. So I would say we have like maybe 1, 2, 3, at least, this is made of 4 aberration fields to be taken into account for simulation, if we really want to simulate this in comp for any reason. Not saying that you would simulate all these, but if you wanted to, you will probably take into account 4 different hues, two in the foreground aberration fields and the other two in the background. So yeah, this is the same wall. You can see the curvature here of the wall, but let's now go to this video here. Let's make sure we are, so this is stabilized, and what I wanted to do was to show you how the focus, the focus plane, I'm doing a rack focus here, so the focus plane is going further away from the camera, so I'm pushing the foreground field all the way in into the scene, and you can see the focus plane moving through the wall further away from the camera. If we go closer, you can see how the background aberration, which as I was saying in the other picture, is kind of these cyans and blue colors, are going to turn into these more red aberrations that we find in the foreground aberration field. So let's now play this, and you're going to see how this area turns red. Is transitioning from cyan into a red. If we saturate this, you're going to see that very clearly. You can see how the aberration changes and how the two fields are moving solidarity further away from the camera. So if you remember my previous chapters in these investigations, when we were talking about those graphics and those slices, where I was drawing the lines and showing you how the aberration was different in front and behind the focus plane, where now you can see that very clearly in this example in action on this video. In this case, you can see how the color shifts because of a rack focus, but also I could be having the focus plane being still in space, and I can walk forward with the camera and you would see kind of a similar effect. Or you can have a still camera on a tripod, and if an object moves in space, you would see a similar effect. You would see how the object is kind of being sliced, but all these aberration fields. Also, let me very quickly show you the first and the last frame, and you can see how much the aberration changes. And I'm not even saturating the image. You can see how this edge is very different. Also, you can see the change in the bokeh. So in this case, in this lens, the background bokeh is more sharper, the cyan one. So it's looking sharper, the edges are more defined, and the bokeh is kind of empty inside, and the foreground bokeh is a lot more softer. That's also very clear to see. And if we saturate, we can now see the change from green to red. So this is going to be the last live action sample we are going to be analyzing before we jump into full CG shots and tricks that we are going to use to simulate all these things that we have been talking about, so we can see how we can simulate them on actual compositing scripts. But I wanted to show you this one because I think it's gonna help for the next, for what is to come on this video. So we can see this scene, and if you pay attention to the girl in the bicycle, so she's hanging around at the beginning of the shot, and I'm with my camera. I'm not paying attention to her at all, and all of a sudden I see her. So I move the focus point on her now, and I'm trying to follow her, so the focus point is moving towards the camera, and then I stop and she gets into the foreground field, both the foreground aberration field and the bokeh aberration field. So I'm gonna be showing you how the colors in aberration is changing in the environment, and how the entire environment is being sliced, and all the fields. In the case of this lens, I have identified 4 main colors, and all of them are moving solidary to the focus plane, the circle of confusion. So everything is moving together, and the entire scene is changing color in the aberration. So let's start with the more obvious thing. Let's try to make this more exaggerated so we can see. And let's start with the further part in the background there. So you're gonna see how the aberration in these trees is going to change from magenta. If you pay attention to this branch in here, you're gonna see how it changes from magenta to a blue aberration, and there it is. Now it's looking blue. So if we go to the first and last frames and we stabilize, we align those frames, you can clearly see how the aberration has changed. So the further aberration field is this kind of cyan color, and you're going to see how it moves all the way, like maybe 50 or 100 meters. So it's a lot of distance, and all the fields move together. So you're gonna see how this color lands in this branch of this tree. So again, before and after, and you can see now how things have changed. If you see this like roof in here, you can also see how it's now kind of in a blue hue. If you take a look at this tree, which looks also magenta, now it's looking blue. And if you see these 2 trees in here, so these ones are in a orange aberration field, but as soon as the previous field, which is like kind of a green, so the blue moves to the magenta moves to the green, and the green moves to the orange, and you can see how this orange turns into a green, and this magenta turns into a cyan. Also take a look at this bench here. So at the beginning of the shot we are seeing the orange field, then it's getting a lot less saturated, because now this is in focus, this is in the circle of confusion, and this is more neutral, not as saturated as is here. So the entire orange field is moving towards camera, gets more neutral and desaturated. And then if we go to the very last frame, you can see now that these greens have moved even closer to the camera, and now the aberration in the bench, even if it's out of focus, we can see that now it's green. So we are going from green to neutral to red. So if we try to analyze this scene in 3D, you would see something like this. Here's the camera pointing to the girl. Let's say the cylinder in here is the girl in the bicycle. Then you have the side trees represented by this line of cylinders. This is the person walking, and then you have some random elements in the shot. These 2 cylinders in here, let's say those are the branches on the further away trees that I was showing you that change aberration from magenta to cyan. And then in the distance we have the bridge over the river. So what I'm doing is all of the sudden I see this girl pedaling, so I immediately move the focus plane towards her. So if we go to this camera and I move the focus plane for 46 meters to where she is, and then I begin to slowly follow her and until she surpasses me and she goes outside the camera. So this is basically what is happening in the shot. So if we go again, at the beginning of the shot we have the girl in the bicycle, and if I move the focus plane, let's say for example, you can see how these trees are going to be sliced by all the different aberrations. So for example, this tree over here that is experiencing an orange aberration, a few seconds later is experiencing a green aberration, and a few seconds later is experiencing some magenta or pink aberration. And let's go again and let's take a look at these trees in the background further away. Again, I quickly move the focus plane towards the girl in the bicycle, but that's gonna mean that these two trees all of a sudden are being sliced with the new aberration field, the one that is cyan, and the rest of the elements and objects in the scene are suffering from the same phenomenon and are changing aberration. Interesting enough also is to see how the orange aberration is getting outside the camera, so now is behind the lens I mean virtually, because of course it's not something that is recorded anywhere, but you can think as is there. And if I were to change the focus plane again, I don't know, say 40 meters, you can see the orange aberration going inside the scene one more time. So yeah, I think it was cool to analyze this scene by this kind of abstraction and doing these geometries and these solidary fields, animating the focus plane and the fields all together, which is actually what is going on with the light inside the lens. So all of this you are seeing here I'm doing, even if you are seeing it kind of outside the camera in the camera frustum, kind of actually if these were the lenses. So let's say this object here, this rectangle is the camera and this is the lens or whatever. Actually everything is happening inside the lens, but I think this is kind of an easy way to represent the kind of what is happening with the light inside the lens. So here we have a scene, and we can see a couple of geometries. We have a few cubes floating around. We have a ground, like an irregular terrain, and in the distance we can see what you might find as being maybe a set extension or whatever. So it's like another checkerboard vertical geometry representing something in the infinity, and so on. And if we see this in 3D, we can see the irregular terrain, these 6 cubes spread across space, and this card representing maybe a matte painting or some kind of similar setup. So the output is this image. When I was starting to think, okay, how can I do to separate the foreground and the background aberration, and for some reason the first thing that came to mind was, okay, maybe using deep compositing I can achieve that. And yes, it's possible, although it's more heavy. But I also later realized in some other scripts that I could do like maybe some cheaper ways, and also ways that I can have better control on what I want to do. So here we have a node controlling the focal plane, which is a deep sample. So let's say we want to focus on this cube over here. So I put the sample node over there, and that's one thing. The other thing to notice here is I have 2 aberration gizmos. FXT Chromatic Aberration gizmo is made by Thor Anderson. And you can probably find the gizmo in Wikipedia too. I am using one aberration for the back aberration, and then for the front aberration I'm using a different type of aberration. So this one looks, the back one looks more like blue and magenta, and if we switch to the front one, you can see the entire frame is shifting to magenta and green. So you have these two. So the background one looks like blue and red in this area, but this is actually going to be the background aberration. So yeah, front, back, and you can see the change. So this is, we are not separating the aberration at this point. So if you were to use, say, this node to aberrate the frame, the entire surface of the frame will get only one type of aberration. And what I'm trying to do here is precisely to separate the aberration on both sides of the focus plane. So what I did was deep recolor to these 2 types of aberration, front and back, and then I'm using this tool or gizmo called Deep Crop Soft. And what it's doing is it has an expression to the sample. So basically I'm just doing an expression to the to one of these values. So I'm kind of anchoring this Deep Crop Soft in the focus plane, and on the other side I'm doing exactly the same, but in reverse. So whatever I move this sample, the Deep Crop Soft is moving accordingly, and the same for the Deep Crop Soft cropping the foreground aberration. So you always have these 2 fields now. You can merge them and combine them. So at this point you have the foreground aberration being green and magenta, and the background aberration being magenta and blue. And you can also let's say you want to do a deep to image after the Deep Crop Soft, and you have to do a disjoint over so you don't get dark values on the RGB. It's not easy to tell here, but yeah, you should use a disjoint operation, or just do a merge combine deep to image. and here I am applying just a defocus. So this node is not applying any chromatic aberration, so the chromatic aberration in Bokeh is not doing anything. So you now have a defocus image with different aberration in the front and back. Also, this deep sample is driving the Bokeh focal plane parameter. So now let's say I want to focus on this cube over here, and you can see not only the defocus is updating but also the aberration. So let's now only focus on the aberration. So let's say I want to focus in here, and you're going to see a harsh transition in the vertical axis. So this is not perfect. I have solved these problems in later scripts, and I'm going to show you that. But for now, this is a very basic setup. So now you see the foreground aberration being magenta and blue. You can also focus. Let's focus in this corner here, and you're going to see how it transitions from the green and magenta. And if we continue here, you're going to see how it changes from the foreground to the background aberration. If I were to focus very close to the camera, you might see how this cube changes from the foreground hue to the background hue. So now you're seeing this cube as being red and blue, and if I move the focus point behind the cube, now this cube is magenta and green. So you can see kind of in action in a compositing script how the aberration is dynamic. This is the harsh line I was talking about. So yes, this is something that might need to be solved. It actually kind of gets solved when I do deep from image on both sides, and I do a 2D join operation. So you can kind of see here how we are transitioning from the foreground aberration green and magenta, and very slowly is turning into a magenta and blue. So yeah, let's continue with some other scripts. And here we are in the same scene, but what I'm doing differently is I'm using some CD focuses, one being like the master controlling the one that is going to be the background field. So, and also I'm creating this very, and I mean very exaggerated bokeh shapes to drive the convolving that the CD focuses are doing. But the reason I'm doing it this way is so it's very clear to see in the tutorial, but of course it's very unlikely that you're gonna find this in the real world. And so one of the defocuses aims to be the front aberration. So the defocus itself is using the filter and the image, so it's picking up the red and the orange, and that is used to drive like this very exaggerated aberration we are seeing here. And of course it's been applied to all the space both in front and back of the focus plane. And on this side we are seeing the aberration is gonna pick up this blue from the blue bokeh there. So the CD focus is actually, these two are creating also not only the bokeh and defocus but also the aberration. So here we have this focus plane here, and also this focus plane is being expressioned to this clamp node, which is clamping the depth. So we are not using deep anymore, we are using the depth channel. And so the focus plane is linked to the minimum here, and on this side is doing kind of similar thing. So if we look how these look in the depth channel, we can see I'm clamping everything, so all the values are getting clamped from the focus point towards the camera on this side, and on this other side is doing the same but reversed. Then I'm copying this weird same thing as the alpha channel for the RGB, or not for the RGB, sorry, I'm just shuffling this to the alpha channel that then is gonna be copied to the RGB coming from the defocus. So now this defocus is going to have this new alpha that came from the depth channel being clamped. So that's a new alpha and it's been blurred. So you can see this is super basic. We are going to see later something a little bit more complex and fancy to kind of achieve this blurring. So it's kind of more representing of more as a spatial, a blur in space, and not so much the two-dimensional blur we are seeing right now. So this is a progression, and we are going to see that later. And then we merge these two branches and we have the foreground aberration field. Then we transition to the focal point and the circle of confusion, where things are very neutral. And if we let this render, so, and then we find the background aberration being this blue color in the background. So we have like this reddish, orange, and this blue. One thing that I want to mention really quickly before we go to the next script is see how these two bokeh shapes differ from one to the other, being this one, the blue one, is like a lot more blurry and meshy, and the red one is a lot more sharp and defined and geometrical. I don't know if you remember in previous chapters on this investigation when I was talking about how some lenses have a background bokeh maybe being more sharp and the foreground bokeh being more blurry and meshy. So this is what I try to achieve here. So you're gonna see this is focus producing kind of this sharpy kind of defocus convolving effect being driven by this shape, and this one is more blurry, just like a simple blur. Everything gets mixed and mushy. So yeah, that's kind of the difference that the two bokeh are producing in the image. So I think it's cool to kind of achieve not only the difference in aberration but also the difference in bokeh properties according to how the bokeh is in front and behind the focus plane. Here we have a render which is one of the test images from openexr.com. You can go there to find more test images if you want. And what I'm doing here is kind of a similar setup. I'm splitting the two fields in front and back aberration. One of the CD focus is the master, and at this point they are also creating the aberration because the filter type is on image and I'm using the input channels. But I could also disable this and use maybe a disc or bladed, and I could activate the chromatic simple 2D chromatic aberration gizmos here, or whatever aberration you want to use. Let's actually do that. Maybe let's just use a simple disk, or maybe I'm gonna use a disk for the front aberration, so it looks softer, and I want to use a blade of 5 sides for the background aberration and background bokeh. So now we have this. Let me just clean this, and if I move the focus point, we are going to see that the depth channel that this image contains is going to help create the defocus effect. So there it is, and this is the same data we are going to use to slice the image in front and behind the focus plane. So again, the similar setup, clamping the depth channel and shuffling to the alpha, blurring the alpha. So I'm getting this part of the image, and then the front side of the image, merge them together, and now I'm having some more like blurry defocus on the foreground and more sharp and bladed one on the back side. And I can now activate both chromatic aberration gizmos, and I'm going to see that they look different. So this one is producing more like a blue halo, and this one here is producing like a green one, and I joined them, and the green one is being used along with the bladed aperture or bokeh for the background field, and the foreground field has the blue halo and the more rounded bokeh shape. So let's do a before and after, and of course this is very exaggerated, but the point is doing it like this so you can clearly see how you can kind of separate this effect, and also to automatically have it updated no matter where you put the focal point. The bokeh and the aberration is gonna get automatically updated in front and behind the focus plane. Let's continue with a new scene. This is a full CG render of a chess board with a few pieces laying around, and so kind of the same setup. And let's see a preview here, so you can see we have some defocus at the beginning of the shot. I'm focusing on the centerpiece here, so we have a foreground aberration describing kind of an orange aberration and kind of a sharp and bladed aperture. We go to a more desaturated area where the focus plane is, and then in the background we can see a more blurry and blue aberration. So this is a very only 20 frames render. If we think for a second what's going on here, the focus plane is moving solidary with the camera, so is slicing all this space while it's moving through the checkerboard. So for example, in frame 10 we can see that the centerpiece is now blurry, and before it was sharp in focus. So now we move forward and it's looking blurry and already picking up the foreground field aberration, and the one in the background that at the beginning was with the blue aberration and blurry is getting into focus in the first 10 frames. And then if we continue to move in the sequence, we can see that now the focus area is kind of behind the board now. So now this piece that at the beginning of the shot was blue aberrated, we can see how it transitions from the background aberration field to the focus plane and into the foreground aberration field. So here you can see how both the bokeh and the aberration is dynamic across the surface of the frame. And again, I'm not gonna go into this one because we have seen how this worked before, but it's the similar setup. We have the two CD focuses, or alternatively we can turn off the use image filter type and just turn on the 2D chromatic aberration setup, or whatever setup you want to use here to create your desired look in chromatic aberration. So here we have our chessboard again, but from in the 3D world, so you can see how the scene is modeled. And here we have the camera flyby over the board, so you can see how it goes over the chess pieces, and also how the scene is kind of being made. So the output of this scene is our full CG shot that you would receive from lighting. And here we have our camera. This is the camera I'm using for render, and a couple of expressions are going out into this script that we are going to see here. So let me go step by step. Here's our render, and our render is being made of the typical output layers that a skyline render gives us, but I also have added normals and world position, and these ones of course are being given to us by activating the vectors and choosing the desired layer name. And so here we are with our complete both beauty and layers for a render. And what I'm doing here, I am remapping P-World to PCAM, so it's like reorienting the position world into the orientation of the camera rotationally wise. So now the position world is aligned to the axis, to the center axis of the camera, and I'm doing that by shuffling the P word and using this gizmo that was created by Mark Joey Tang. So you can check this, and probably you can find the gizmo over the internet or in the creator website. Is very useful. In this case, I'm using this to convert position world to camera position, and shuffling this into the stream again. So this is giving us our new PCAM path, which I'm gonna use later. So let's go step by step. Here we have our defocus. This one is not being used, so I'm not using the output of this node. This is just like a driver for a few other things going on downstream. But basically here we can see a position mask. There are plenty of gizmos like this. Some are called P-World or P-Mask and such, which they use position data to pick values and make those values into masks that you can select and move around and keyframe, etc. So basically what I'm doing is, in the case of this particular node, I'm using the P word, not the pcam, but I'm using a few expressions here. So what I want to do always, in the same way that I do in some other examples, I want to kind of have control of the focus point, and I want everything, the foreground field and the background field and all the nodes involved in this operation to move solidary with the focus plane. So one way to achieve that is go to the camera and use the camera position and the camera rotation. So I'm creating an expression from the camera into the position on the matte shape. So this is the center from where I'm picking a value, but instead of using the picker and picking the viewer, I'm expressing the camera to this knob, and now the center of selection is moving solidary with the camera. And I'm also using the rotations of the camera, and I'm just expressing them to the rotate of this node, and also making sure that the rotation order is the same as the one that I have in the camera. So that will give me a selection centered where the camera is. So now you have to think that the selection center is kind of out of frame, so it's outside of the camera frustum. So if I have to show you that in 3D, and this is our camera, so the selection center is now like here, so there's nothing that we are going to see at the moment. So we are actually going to see something because I already did that. But if you were to do this from scratch and you go to the alpha channel of the position mask, you would actually see black here. So in order to see something, you of course have to increase the scale. And as you can see, the scale is scaling from the center of the camera through the rest of the scene. So I'm using 50 meters as the size of the field here. And so this is a way of creating the foreground field. So everything being white in the mask represents the foreground field before the focus plane, and everything being black in the mask or in the alpha channel in that case is everything black represents the background field. Then I am shuffling everything to the alpha to all the channels, so I can have visibility of this mask at all times. I'm just blurring it a little bit, probably to deal with anti-aliasing issues here. Of course you can deal that in a much more fancier way, but that's what I'm doing here. So here we have our our controller for our background and foreground fields, and I'm just simply using a red aberration for my front aberration field, and then I'm using a green and blue aberration for the background. So everything in the back is gonna be blue and green, and everything in the foreground would look with these red and kind of cyan halos. So here's our mask, and the mask could be whatever you want. It could be located in some other position. And one more thing to mention is the smoothness is a smooth one. And then the driver for the smoothness in the position mask is actually Probably the depth of field here. Yes, in fact is the depth of field. So this is selecting how much of smoothness we have, and it makes sense because that's how much depth of field is giving you how much is in focus or out of focus. So if I change these values, you can see how the mask is getting more kind of clumpier, and is very clearly describing where the focus plane is. And if I increase the depth of field, everything being going from white to 0 to black is what we could call the circle of confusion. So this is kind of still going to be perceived sharp to our eyes as this focus plane located in here. So let's use, I don't know, a value of 4, and now we can mix both aberrations and fields here, and now you can see the red and the blue field on the foreground where our focus point is selected from our focus plane master, and from here to the background things begin to turn blue and green all the way to the distance here, as you can see in this ground. Another thing that I wanted to show you before we move to the next script, here in the aberration fall off mask, is how if we see this in playback, you can see how the focus plane is moving with the camera, slicing all the chessboard and the chess pieces. And you can see the circle of confusion, the transition between pure white and black. Everything is moving together and making the foreground and background aberration change. So let's, for example, use a smaller transition here. Maybe we can see clearly how the elements in the scene go out from the background field into the foreground one. And I don't know if you're going to be able to cache this and create some sort of playback here. So this is going to take a couple of frames, so I'm gonna show you once it's cached. And here we can see the shot in playback. Things are happening very fast, but if we look at the controller mask, here we can see what's going on with the focus plane and the circle of confusion, and the foreground field being white and the background field being black. So again, if we look this in RGB, and if we analyze a little bit of what's going on, we can see that the aberration here is blue and green, and then that's going to immediately change because we are using a very small depth of field. So you can see how quickly this piece shifts from the foreground field aberration to the background one in a few seconds. And the cool thing, you can see how the colors also kind of blend in the circle of confusion. So you have the background, the foreground field, then it transitions in the circle of confusion and turns kind of this violet, and then until it gets fully to the background field and shifts to red and blue. The rest is happening with the rest of the pieces in the board. You can see how the transition happens in those frames. If we focus on this one in the back, it all of a sudden comes into the foreground aberration, and in here it was in the background aberration where everything is kind of this green and blue. If we see this one, The same, we're going to see that at the end of the shot has now turned blue or cyan and red. It all depends if it's transitioning in the circle of confusion or not. So yeah, you can see how the camera flying over makes kind of a slicing across the scene and changing colors. Again, kind of the theory we saw in the first chapters of this investigation, but now kind of in action. So let's continue now, seeing some kind of thinking process. So all of these scripts you're seeing here, it's like I'm not trying to show you this as templates or tools or the solution to anything. So it's a thinking process. And for example, at this point I remember thinking that, okay, I have this picture, don't know if you remember this one, from the Helios 44, and I thought, okay, maybe with a Voronoi gradient I can kind of sample the aberration again and create like a mapping in the entire frame. And I remember thinking, okay, and this is something I have not achieved yet, but I just remember thinking, how cool it would be kind of to sample the aberration, and then use the position pass or the camera pass, the camera orientation pass, to kind of spread in space all the aberration values. So it's kind of the information is there in the position pass. So this is something that maybe some of you guys, if you want to think about kind of how to map color data across space in a position pass, or maybe with expressions, I think that's kind of a cool path to explore. But okay, so I have this picture and I thought, okay, I'm gonna mirror it and I'm gonna spread kind of the same thing up and down and side to side, and I'm gonna use a Voronoi gradient and sample all these pictures, all these kind of aberrations, all these colors, and I'm gonna try to create a map. And once you sample these, by the way, this gizmo is awesome. You can get it from Wikipedia probably. I think I got it from there. And if you see the result of this Voronoi, is giving you this. So it's very basic. It's like, but still powerful, because it's kind of giving you how at least you can see and make an idea of what's going on. And okay, I remember thinking, what if I try to combine this with a position, for example, and I'm gonna do a position 2 points, and sometimes I kind of need to see things maybe by like in a very obvious way, and by doing that it's like maybe I see this one day and I don't know, maybe a couple of weeks pass and some kind of idea pops up. I could be in a very busy week at work, and I can leave this and then come back later and oh yes, and now I have this other idea. So for example, I have this RGB here, and I remember thinking, okay, maybe I can kind of extract edges detail, and so I use this high pass gizmo. This one is by Tony Lyons, so this is probably, you can find this one in Wikipedia too. And this is giving you kind of this result where you can extract high frequency detail, and I thought, okay, I'm gonna blur this a little bit, and then I have my aberration map here, and I can multiply both, and that's it. I mean, that's the thinking process. There isn't any, and it doesn't get any fancier than that, but you can see kind of I'm getting this aberration in the area where the aberration is maybe more orange, and then I'm getting some green aberration in these places, which comes from here. So yeah, this particular thinking process didn't make it like further than this point, but as you can see, a little branch goes here to the side, and this kind of new thinking kind of opened the way for the next and final scripts we are going to be seeing, which are a little bit more elaborated, with some possibility to a potential gizmo here. And I thought, okay, so I have this idea here, so it's like maybe I can create these two fields of aberration in space, kind of more basic, in a more basic and very clear way. So I have these two colors that I have sampled from the Voronoi sample. So I have these two constants, then a deep recolor. So I have the deep information coming from the skylight render. And again, I have a deep sample here to drive where I want to do focus. And this is similar to the first setup we saw. So we have a deep crop soft, and whatever I do focus, I have my aberration field, which is picking the constant color. The same is happening here, but in reverse. And if I join the both in the circle of confusion, I get something like this. And if I do a deep to image and do a disjoint, I get a more precise union in there without the artifact. I also because I like to get out of any deep setup as quickly as I can. Here you can see the final result, right? We have this, and then we have this other idea that came from this other high pass in here, and I'm using these two. I multiply them, and now I kind of have a sort of a solution. I'm saturating this, and if I move the position of my sample, the aberration moves accordingly. If I sample very far, everything turns foreground aberration. And here you can see the frontier between the back aberration and front aberration, and so on. I can focus on different parts, and everything is gonna remap automatically, even if the camera moves, or I can do keyframes in my focus point and animate things to maintain focus or change focus from one subject to another subject that I want to create attention. And here we have our RGB and a simple plus in this case. Things are getting tinted also in some other areas. It's not just the high frequency detail edges, but also the entire frame, which is actually what the aberration is doing in the entire frame, although you don't perceive it, but the aberration is everywhere, and is more increased in the high contrast areas. So in here you can see that the black point here, the darker area, is also kind of getting tinted a little bit. You can correct the luminance change by a from and a plus, kind of doing something similar when you dispel and you do keying operation, the speed operations. But yeah, kind of the entire frame, as you can see, is getting like tinted, but more in the high frequency and contrasty areas, and not too much in the rest of the frame. So yeah, part of the thinking process, color, another recolor here to feed into this bokeh. This bokeh is also expression to the sample, driving everything in this setup. So now I'm moving the defocus and the aberration all together at the same time, with just moving the position of the sample node. So here we are with our chessboard again, and I'm doing the usual thing that I did in previous scripts. I have my controller here with the mask generator linked to the camera, so we have our focus plane anchored with the camera, and if the camera moves, the slice of the focus plane is gonna move with it. But what I wanted to show you here, in this case, I'm not using chromatic aberration inside the bokeh, so this is just a disc, and this one is also a disc. We could probably make the other one a blade just to make it look different. So we have our two defocus sets here to create two different bokehs, and this is kind of an idea I had, that I was actually working on a project the other day, and I was doing some defocus to a full CG shot, and for some reason I thought maybe I can use this eye transform gizmo to kind of change the image by using this mask, or you can also potentially use position data, or C depth, and so on. So let's turn off this invert. I'm gonna explain later what that is, but for example, let's say I have this eye transform gizmo and I move it 10 pixels, and you can see that because I am using the foreground field output mask, whatever I do with the eye transform is happening from the focus point towards the camera, and if I invert this mask, the opposite is going to happen. You can also not translate, maybe scale from the center of the frame, and it would look something like that. Of course, this is very exaggerated when you're probably, if you're gonna use something like this for chromatic aberration, you're gonna be working with fractions. So yes, that's kind of the idea. And also, like if you want to create kind of a more bleeding effect for the aberration, and let's say I only have this blue happening, this blur happening in the blue channel, if I increase this, it's only going to happen in the background field. If I turn off the invert, it's going to happen in the foreground field. So kind of you can play with these two ideas here. And if I now go back to our branches, the front aberration and back aberration, I'm splitting the channels. So for example, on this side I'm transforming the red and blurring the green, and that's gonna give me something that looks like this. So if we turn this off and on, you're gonna see the effect. So just by transforming the red, I'm getting probably enough, and this is very exaggerated, but it's for you to see in this video. And the background aberration remains untouched. I'm doing the same for the background field, so you can see that the background field is carrying kind of a mustard and blue hue. I'm transforming the blue channel by scaling, and the green channel is getting blurred. So you get this kind of yellow, but also by blurring the green, you're getting some kind of more interesting and just an extra green color there that mixes both with the yellow and the blue. So you're kind of creating this kind of cyan. So yeah, you're jumping from 2 colors to 4 hues. So you have kind of 1, 2, 3, 4, maybe 5. Not sure if it's most of the time you're not gonna need to add so much richness, but it's there. And then I'm mixing the foreground and the background aberration field by using the mask. So here you have your background, your foreground, and key mix, and that's it. You have the foreground and the background aberration field, and a mix of the two happening in the circle of confusion. So even if I'm going to show you a few more scripts that we have here, for me this kind of setup here, this kind of template where we have our full CG shot and we are having a controller for the foreground and background aberrations, and then we have a master control for all the parameters for the CD focuses here in both branches, the foreground and background aberration branches, foreground and background bokeh. You can have control of the aberration inside the CD focus, or you can turn that off and doing that downstream by aberration by displace. So you use the mask controller to drive a night transform gizmo or on one channel and maybe blurring on the other channel. You know, the possibilities are up to you, but what I want to say is I believe that at this point and in this investigation and all the things that I have tried before, I think that this is enough to solve the issue of, okay, how can I aberrate differently in front and behind the focus plane. This is totally enough in my opinion. I definitely, me personally, I'm not gonna go more complex than this template on my everyday comps, and so yeah, I'm kind of happy with this. This is probably sort of the thing that I would use, and whatever I'm gonna show you next, these 3 scripts here, this is kind of more an overkill situation. I wouldn't do this on my everyday comps at all, and I also think that these things are more on the research and development territory, programming, render engine programming, all those things that totally and absolutely escape my understanding and knowledge and experience. I'm not a programming, I don't know how to program. And definitely you wouldn't be using or creating scripts like this every day, I believe. But yeah, I'm gonna show it to you in case this could be a spark for some other idea that you might have and you wanna develop further. In this next script we are going to see something a bit different. So I thought, okay, I don't know if you remember this picture where I shot an array of dots out of focus, and I'm now focusing in the center of the screen of my computer monitor screen. So then I saturate this, and I'm kind of using the color picker to give a color to all these constants. So these represent all the aberrations being rendered by this lens, this real lens, I mean. So you can kind of think about this as a principal photography kind of data capture of the aberration of a particular lens. Maybe you're working on a project where you're working on a sequence where you are cutting from a live action shot to a full CG shot that is similar to the live action one, so they share maybe elements, and then you're cutting again to the next shot being a live action one. And this would be in the context of maybe a lens that is rendering very noticeable aesthetic signatures and things that are very noticeable in the aberration. Maybe it's an anamorphic project and it's giving you a very noticeable and distinguished look. So maybe, just maybe, something like this can help you to kind of copy a little bit of that lens. And once you set this up, it kind of works automatically. So you can use it in a couple of shots, and you can rack focus and do things, and everything will update. So what I'm doing here, we are again in our chessboard, and I'm doing the usual thing. We have our two branches, we have two defocuses, we have our aberration by displace, or actually this could be whatever 2D aberration technique you want. You can totally not use that, and maybe you're using an aberration gizmo here or whatever you want. The point is to explain a little bit of what's happening here. I'm using P masks to slice all these aberration fields that we are seeing in the capture. So you are going to see the chessboard that we have here. You're going to see all the slices in depth, and every slice contains the aberration hue. So you see things like this. You have one, another one, here you have another slice, and you can see the foreground cylinders here being cutted out. Here you have the next slice in depth, so as you can see the jump here is from one slice to the next, and then you're getting closer to camera until you exit the camera frustum. And if we join all these slices, you can see all the aberrations separated in depth, and if the camera moves, all the aberrations move solidary to the focal plane and to the camera. and that would mean that then you can use this kind of three-dimensional aberration kind of mapping technique, which by the way is very simple. This is creating an alpha channel. The only different thing is, but actually not, there's nothing different. I'm using p-word to create these slices, and then I'm rotating the output mask by the same rotation of the camera. So then I'm using just these alphas here to pre-multiply the constants that are coming from upstream, and copying an alpha there, pre-multiplied. And so as you can see, it's pretty much a brute force technique. This is far from being an expression or programming or something like that has been built from a position pass, or maybe a camera position orientation pass that is remapped to colors, and that would be something cool to see. I don't know if you have ideas for that, but so now we have our chessboard here, we have our aberration fields, and what I'm doing is I'm kind of creating this high contrast luminance mask, and I'm doing an average of both things. So I'm saturating, or not, no, I'm not saturating this, I'm blurring it a little bit, and I'm doing just a simple average of both things. Nothing crazy here at all. Brute force techniques, very basic. Then I am applying our defocuses, and so the name of this backdrop I like because it says color correction and tint. So actually, as I was saying before in this video, the aberration is everywhere. Sometimes we don't understand why some colors in the frame change, and it's probably because maybe the lens is racking focus, or maybe the camera is moving in space, or maybe the objects are moving in space toward or away from the camera. That creates like subtle hue changes, and I believe it's because of the aberration. So this is, you can understand this as maybe a way of kind of doing a very initial and very subtle color correction. So if we grab a color correct node and we saturate the image a lot, so you can see like kind of we are introducing kind of a green in here, and not so much in the over here. This area here is turning like a little bit kind of a brown in the midtones. Also the black point is very subtle, having a hue shift, very subtle. And so yeah, I would say this is a way kind of color correcting your image based on the aberration. Then you do the defocus front and back, and then you apply the aberrations, and you join both fields. So yeah, that I would say this is something that would need to be probably developed further, if it makes sense at all to use it. I don't know, it's just an idea, maybe can be used for something else. Alright, so let's say that maybe you're working on a sci-fi project and you get a full CG shot like this, and so we are looking at the final comp that I did pretty quickly, and you have these kind of drones flying over this perspective of a city. You have a few highlights from this tube, this kind of vertical tube lights, and you have the nice city buildings, lights, rendering some nice bokehs in the background, in the foreground, everywhere. You have some dynamic bokeh changing from the drones coming from the back to the front, and also the ones coming out of the camera are not also changing, and the bokeh shape from the front and back bokeh, but also the aberration is changing across depth. Let's take a look at this area here. So you can see how this vary, and again, this is not realistic, but I have done the bokeh shapes to be very saturated and distinguish between the background aberration and foreground one. And you can see how the same lights change during the rack focus. So I'm moving the focus plane from further in the distance towards the camera. So what I'm doing is I'm trying to follow this drone in here, this one that I'm pointing. So the focus is moving with that drone, and kind of everything else in the city is changing both bokeh shape and aberration at the same time. So the foreground bokeh shape is more sharp in this case, and the background one is more blurry. So you can see how also the further away city is picking up those blue bokehs, blue aberrations. You can see that drone going into the circle of confusion and then entering the background aberration field. So you can see how in here is in the foreground aberration field, and then it enters the circle of confusion and goes to the background aberration field. So here we have our first layer of this full CG shot, a bunch of clouds, then we have the city. This layer contains a bunch of passes, so we can see depth, we can see position, motion blur, normals, and the usual thing that you might get from a full CG shot coming from the lighting department. Although this is very simple, we don't have lights separated and we are not splitting and rejoining anything. This is just for demonstration. Here we have our tube lights that are being C-merged, so I have them in the depth channel 2. I'm converting my P-World to a P-Cam. This is the camera that was used to render this image, and then this is our render now. So this is what you would bring into Nuke. You would bring the camera, you would bring this render, and you have now have you have the P-World, but you have the P-Cam. This one is we're gonna use the blue channel from the P-Cam to drive probably much of the defocus effects and aberrations and stuff. So going back to our shot, this is the usual thing. I'm doing a mask extraction from the P-Cam pass, and as you can see, the focus plane is animated. So I'm trying to follow one of the drones, this one over here, as it comes close to the camera. So here I'm doing kind of a similar thing. I'm trying to kind of sample a real lens. So let's say that for whatever reason this is the plate that you want to sample from. Let's say the previous shot from the shot is a live action one and it's describing these aberrations, and for some reason you want to mimic and do all this scripting here. So these are the colors that I have sampled from that plate. This is the furthest one and this is the closer to the camera, and all of these are the intermediate hues. So I also have controllers for the aberration field size and the aberration field falloff. So I'm doing again controller masks that are expressioned to the camera and to the CD focus controller. So each of these hues has its own alpha in depth. So, and also they automatically rag focus when the focus changes, when the camera does the rag focus. So each one of these hue fields is moving in space. So you have this one is further away, getting closer to camera. If you remember the plate from the girl in the bicycle, kind of similar, a similar thing was happening where you could see how the aberration fields in the real world was moving forward solidary to the focus plane. So I'm doing the exact same thing here. And if we join all these hue aberrations, you can see how they move together solidary to the camera. So let's cache this really quickly, and you can see how all these masks, P masks, generators are moving together. And then I'm using this further away hue just for the infinity, so you would see something like this happening in the rag focus. You can see also how the drones change hue as they move through the scene. So maybe you have this one describing this aberration, and a few frames after is orange, then is cyan, then is green, and then is a lighter green. So I kind of imagine, to me personally, this doesn't make much sense to create something like this in comp, at least unless you are working maybe on a single shot that needs this treatment. I don't believe this is something that is doable in multiple shots and or in a sequence with a lot of similar shots. I would definitely go with something simpler, like the one I was showing you before. So I believe this is more on the render engine side, or some kind of gizmo that potentially takes the position, both, or maybe the world position or the camera position pass, and kind of map all the aberrations in 3D space, and this is kind of rendered or is created by a gizmo automatically with expressions, or this is coming out of the render engine straight out of Maya or Blender or whatever, and you would have something that would be kind of an aberration map or something that you can use to maybe mix with some detail extraction or high frequency extraction that you do from edges in the plate or whatever, or in the render, and you use that kind of aberration pass if you want to create kind of a very realistic three-dimensional and dynamic aberration at all. So here you have your full CG shot, and what I'm doing is I am doing an over here, just nothing fancy at all. So you can see how this pass is kind of doing a color correction all over the frame. So now the entire frame is being aberrated in the darks, in the highlights, in the midtones, and then I'm recovering the same luminance by a from and getting rid of the saturation and doing a plus. So you're adding all those nice aberration changes, but now the luminance remains untouched. If we saturate this, we're gonna be able to see what's going on. So let me show you the before and after. So that's before and this is after. So it's very subtle, not even by saturating too much we are able to see. So that's before and after. We are 4 in the saturation, so it's a lot, and you can see how the saturation is picking up. Also here in the background you can see we are picking some other aberration hues, and in the background the aberration hues are totally different, but all of these hues are reflecting the hues from the live action, from the real lens using principal photography. Or you can create this your own, and you can create your you can design your aberration however you want. So if you go to normal again, you can even very subtly perceive the changes. So again, it's a very subtle color correction. So I would say doing this in these two branches is very like a color correction setup, and then you have your foreground and background defocuses, the usual thing, and they are also updating with the focus plane. And here you would have your if you want to use them, I'm not using them right now, so this is turned off. You can use your 2D chromatic aberration setup, but I'm using these two bokeh shapes here, this one, the very sharp one, and the blue one, to drive the aberration on this shot. So this would be like a pre-render of our comp, and then I'm doing some extra treatments, adding a few elements like this smoke and some foreground smoke, and maybe color correcting again, adding some rain elements, and this is our final shot. So you have started with a full CG shot that doesn't have any lens treatment, and now you have lens treatment with on one side you are applying kind of a color correction, and doing a very subtle aberration in the entire surface of the frame. And then you're kind of treating the shot with different bokeh shapes for the foreground and the background areas, and you're also adding different aberration fields for the background and the foreground, so you can see how the shape and the aberration changes. So let's say that now you're working on your sci-fi project. I don't know if a shot like this rings the bell. And so you have your spaceship here, and all those white array of white squares represent kind of maybe lights, internal lights in the ship. And in the background you have the space, all the stars and everything else, and that might be happening in the shot. And this might be a similar setup where I say, okay, maybe I want to use this lens to mimic all the behaviors for this full CG shot. And so, okay, I have this lens, I have sampled the lens, so now the lens aberration is captured, and I am joining all the aberration fields. So you can design how much wider and these fields are, but what is realistic here is that they are placed in the same way they behave in the live action lens. So now I am slicing the position pass or the camera pass in this case, so I'm feeding the PCAM pass to these position mask generators. So instead of using the P word, I'm using the PCAM as the pass, and I'm joining all these aberration fields. So here you see all the fields with fall off. You can create that fall off inside this P position and such. There are many nodes and gizmos that do the same, and I'm rejoining them by a disjoint operation. And here we have our aberration fields. So in this case you can see how we have a stationary camera and the object is being sliced by all the aberration fields while it's moving through space. Now we can use this map to do our color correction here. So in this case I am first doing a defocus of our shot. So I'm using this bladed aperture for the background field, and I'm using a rounded one probably for the, yes, it's a rounded one as you can see, and I'm using a rounded one for the foreground defocusing, and then I'm doing our color correction. So you can see how the aberration is tinting maybe the foreground aberration field in this particular frame is looking pink. Then we get into the circle of confusion where things are sharp, and then we transition to the background field and we can see how things are getting tinted a little bit green and more kind of bluish green in the further distance. You can see the stars picking up the same aberration field. So now we have color correction and defocus for our background and foreground, and here I'm adding a more kind of a strong typical aberration. So I'm using a I transform being driven by our mask, and our mask is being inverted on this side, so you have the foreground mask, the background mask, and they are of course animated in space with the movement. So the object moves, but the mask is still, because of course the camera is stationary and the focal point is fixed in space. So you can see how the spaceship is entering the foreground field here. And if we see the RGB, we are going to see the aberration happening here, very exaggerated, so you can see it, but it's more kind of an optical thing. Maybe if you have small lights from the inside of the spaceship, you are gonna pick up this nice variation, so it's gonna look like this in here, but maybe right here it's gonna look more green and blue, and maybe up here it's gonna look different. I'm doing the same in the other field, and then I'm joining all together. So here's your final shot, and of course everything is very exaggerated. Things wouldn't look like this on a comp, of course, but this is for the sake of the visualization in the tutorial. So with this script we have now finished our investigation. I hope you enjoyed this video. I know it has been a long video, but I wanted to cover not only the concept of background and foreground, bokeh and aberration, but also I wanted to talk about the basics of aberration in the first chapters. This has also been a learning experience for me, so just by investigating a lot of these concepts, I have kind of came with the solution that I was telling you before, that I think is more kind of a simple script like this one, or even maybe simpler than this. There you can even use less nodes here, and maybe someday, of course I don't think this is an everyday thing, but if someday you kind of wanna treat your aberrations differently in a full city shot, or maybe you are working in a live action shot that needs to integrate a CG image into a very distinguished and very particular lens and aberrations that sometimes are has very strong, signals and colors, and or maybe you are working in a night shot of a city and you have a lot of lights and you have to integrate something in there, and you want to kind of match the aberration and the objects moving in space. Anyway, you can see the concept, and maybe you can go back to this video one day and make use of it and use it in some of your comps. So thank you so much for watching this video, and until next time.